Bristol Community College, Mathematics with Dan Avedikian, Math 060, Topics in Developmental Mathematics, Section 2.8, Problem 19. This is Section 2.8, Problem 19. It says complete the computation. We have 5 over 6 plus 5 over 12 plus 5 over 24. So we do have a common numerator, but that doesn't help us. We have to get a common denominator. So we're adding 3 fractions, but it's the same process. And again, I like to write problems like this vertically. So 5 over 6, 5 over 12, 5 over 24. So whether you have 2 denominators or 3 denominators or 8 denominators, it's really the same process. What I want to do is take the largest denominator, in this case 24, right? My choice is 6, 12, 24. See if all the denominators divide in evenly. And in this case, they do. 24, of course, divides into 24 evenly. 12 divides into 24 evenly. 6 divides into 24 evenly. So that's a common denominator. If it didn't, I would double it, try 48. If not, then triple it, try 72, and keep going until I found the denominator they all divided into evenly. But I got it on the first try. They all divide into 24 evenly. So change each fraction into an equivalent fraction that has a denominator of 24. And I know right now that will be the denominator for my answer. My answer is going to be something over 24. Now what we have to do is work on the numerator. So you can really fill them in whatever order you want. I'll just start from the top, go right down. 6 times some value became 24. That some value must be 4. 6 times 4 is 24. So the numerator gets multiplied by the same value, in this case times 4. 5 times 4 is 20. So this is the first fraction. 5 over 6 has an equivalent fraction of 20 over 24. Now the one in the middle, the 5 over 12, what does that turn into? Well, look at the denominators. 12 times something became a 24, so it was times 2. 12 times 2 is 24. The numerator must be multiplied times that same amount, in this case times 2. 5 times 2 is 10, so 10 over 24 is equivalent to 5 over 12. Now the last fraction, in this case the last one's super easy. The denominator just got to stay the same. It was 24, it stayed 24. So the numerator will stay the same also. It was 5, it just stays 5. 5 over 24, of course, is equivalent to 5 over 24. But now what I have is 3 fractions to add where all 3 fractions have the same numerator, same denominator, I meant to say. So this is an addition. I'm going to add them together. 20 plus 10 more is 30. 30 plus 5 more is 35. So I have an answer of 35 for the numerator. The denominator, again, I knew was going to be 24. So I have an answer of 35 over 24. Now, while it does not reduce, this is an improper fraction, I can convert it easily enough to a mixed number. Some math teachers are fine leaving your answer as an improper fraction like this, 35 over 24. Others prefer a mixed number as the answer when something like this happens. So if you remember how to do this, I'm going to go off to the side, divide the denominator, in this case of 24, into the numerator of 35, see how many times I can get it to fit in, and then look for the remainder. So 24 won't go into 3. 3 is too small. It will go into 35, but only once. 1 times 24 is 24. And now I can subtract 35 minus 24. 5 minus 4 is 1. 3 minus 2 is also 1. So there's 11 as my remainder. So the remainder becomes the numerator of the fraction, and the denominator of 24 stays the same. So my answer can be written as 35 over 24. That is the answer. Or if you prefer the other form, it would be 1 and 11 over 24.